Serverless functions are amazing. They scale to zero, they handle traffic spikes, and they suffer from total amnesia. They are stateless. Want them to store state? That will be a round trip to a database halfway across the world. 200 milliseconds of latency while your users watch a spinner. Enter durable objects, a primitive from Cloudflare that somehow makes stateful serverless not sound like an oxymoron. While a standard Cloudflare worker spins up in whatever data center is closest to the user, a durable object is pinned to one specific location. It gets a globally unique ID, and Cloudflare magically routes every request for that ID to the same physical machine. It's basically like an on-demand mini server, and instead of scaling up, you just spawn millions of them. Horizontal scaling. Every durable object has a full SQLite database baked right into the runtime. All database reads and writes are fast and synchronous because the database lives on a local SSD on the same physical machine. No external database, no round trips, no 200 milliseconds of latency. But how does Cloudflare actually make these writes durable? Because yes, that's literally what the name says. Enter output gates. Whenever a durable object tries to send a response or make an outbound network request, that communication is blocked by an output gate. In the background, the runtime replicates your writes to 5 follower machines and waits for at least 3 confirmations before opening the gate. This means you get fast synchronous writes and good consistency for free. Let's deploy a stateful counter. First, we import durable objects and define a class. In the constructor, we initialize the storage and then just write SQL, create the table, increment the counter, and return the result. Notice how we don't have to await the database calls. We'll also create a worker to handle incoming requests and send them to the durable object. I'm using the request path to generate an ID and use it to get a stub for the durable object. Now we can call RPC methods on the object and return the response. To deploy, we'll create a wrangler.toml file with the durable object binding. Finally, let's run the deploy command. We can now make some curl requests to test the durable object. With durable objects, you can maintain long-running WebSocket connections without paying for idle time. This is called WebSocket hibernation. To do that, we first create a WebSocket pair and then hand it off by calling the accept WebSocket function. Cloudflare can now hibernate your durable object when it's idle. We use serialize attachment to store a small amount of state and attach it to the socket. This state survives hibernation and is used to identify the connection. When a message arrives, Cloudflare first wakes up and initializes the object. And since durable objects run on P8 isolates, just like standard workers, this startup takes almost no time at all. Then it triggers the message handler. You just call deserialize attachment to retrieve your state, identify the user, and handle the message. What if you need async jobs? Durable objects has you covered. With alarms, you can schedule a durable object to wake itself up at a specific time in the future. Just call the storage.setAlarm API and pass in a timestamp. This could be 10 seconds from now or 5 years into the future. When the time comes, Cloudflare wakes up your object and triggers the alarm handler. This simple API makes durable objects infinitely more powerful, unlocking possibilities like scheduling, reminders, batch processing, cleaning up stale data, or handling payment subscriptions. Let's talk about pricing and limits. Unlike standard Cloudflare workers, where you save money by only paying for active CPU time, durable objects charge for wall clock duration. You pay for the entire time the object sits awake in memory, plus a small per request fee. Each instance is also strictly capped. 128 megabytes of RAM, 10 gigabytes of storage, and a soft limit of 1000 requests per second. Continuous CPU execution is capped at 30 seconds per request, though you can pump it up to 5 minutes. This means you shouldn't use durable objects for memory-intensive workloads or as a global bottleneck for handling massive concurrency. Instead, design carefully so that you spawn lots of tiny objects to fully leverage the speed, co-location of compute and storage, durability, and horizontal scaling. This has been Durable Objects in not quite 100 seconds. But thanks for sticking around, and I'll see you in the next one.